Did anyone get this one?
Not yet.
No? Give you another minute. This one's, anybody got it? You need to phone a friend? Okay. All right. So C 17.3. Do you guys remember? You add them all up, divide by the number of values. Do you remember this briefly? Is it ringing a bell? Did you just forget the chi-square? What instrument does this go with? Usually.
The well counter.
Yeah, the well counter or the uptake probe. We do this test. So it determines the acceptable range of variability. So do you remember, you get the list, you add them up, divide by how many there are. You take the average of all those, and then you see how far is each individual one from that average. Okay, so then you would plug it in here, square it, and divide by that average that you got, and you'll get that number. Okay, does that sound right now that you remember it? Add them all up, divide by 10, see what that average is, and then go to each number and see how far it is from that. Ringing a bell now? All right, I'll do another chi-square on your next review. All right, we'll do one more. They don't usually give you anything too difficult, so I could even give you a 4. Usually would do more trials, but I could give you an easy 4 trial one and you'd get it. All right? All right, which expression describes the operation of the gamma camera in the previous question? So we got an answer for the chi-square of 17.3. So which of these it would be correct associated with that?
Does anyone answer?
Yeah, anybody. What do you think, Teresa?
Would it be too much?
Okay. Yeah. So too much is correct. Nice job. Very good. That is too much variation at 17. Okay. I don't know if you guys remember the p value and all of that, but yeah, that's too much. So usually we use that p of 0.90, and the 17 value is too much variation, not too little. We like it a little closer together in the numbers. And sometimes you can tell, obviously, from the numbers right off the bat that they're too far from each other. Sometimes it's obvious. And they do sometimes give those kind of on the board. That's just a general concept. You get the idea. All right, a Molytech generator is calibrated for 1 Curie of Moly at 7 a.m. on Monday. The generator is eluted daily Monday through Friday at 8 a.m., but the workload is especially heavy on Friday. So the generator is eluted again at 3 p.m. to obtain more tech. Assuming 100% elution efficiency, how many millicuries of tech will be eluted at 3 p.m. on Friday? take you guys a bit? What do you think? Trying to just get you guys to think about how would I solve this? How would I solve this? Is this one that's going to take me a few minutes to work through that? What do you think? If anyone gets it, just shout it out.
I
Lindsay?
just have a quick question. Is it
Yep.
supposed to be just Monday through Friday at 8 a.m. and not 7 a.m. Monday?
Oh, Monday to the calibrate for 1 at 8 a.m. Generally saluted Monday to Friday at 8 a.m. Well, it's calibrated on 7
okay.
a.m. on Monday, but they eluded an hour later
Okay.
every day. So it's kind of a long one. Spoiler alert, look away if you don't want to see and you want to try this at home, okay? Look away. All right, spoiler alert. All right? If anyone got this, you can pat yourself on the back. Some of these questions I've picked are as hard as nails. This is as hard as they get. If you can get this one, anything they throw at you will be piece of cake, okay? So if you didn't get this one, come back to it, sit down and write it out. Okay, this is what happened on Monday, Tuesday, Wednesday, all of that, okay? So you've got the answer there so you can check your work. All right, tough as nails. Let's move on to the next one. A radioactive source of cesium-137 with a 30-year half-life was calibrated on October 23rd, 2015 to contain 10 microcuries. This is used as a daily accuracy check source in the dose calibrator. Presuming that the dose calibrator is working, what activities should the dose calibrator show on April 23rd, 2021? Okay, plug those in. This one definitely shouldn't be as mentally challenging. Anyone get it?
Is it B? B as in boy?
Nice job. Excellent job. Absolutely. So using that equation, plug in that information. As long as you've got the right time between those two, you should get 8.8B. Excellent job. If you didn't, just keep going back and working on those. Sometimes just a matter of time and pressure. All right, a source of F18 T1/2 approximately 2 hours is noted to contain 3 millicuries at noon. You'll notice that they like to estimate things sometimes in these questions. What was the radioactivity at 8 a.m. that same day? This one's kind of conceptual if you use what they gave you at the 2 hour mark. Who got it?
Is it C?
Nice job, yeah. So yeah, the difference between these two times is 4 hours, right? And if we know it's every 2 hours, we're just going the other way, right, with it. So if you had 3, then it was at 6, right, at 10, and then at 8, it would be double that, which would be 12. Conceptually, everyone gets it? You're just moving the other way, pre-cal versus post-cal. You can actually calculate it, plug it in, or you can just use the concept question. A lot of times that's what they're saying. Do you get what half-life is? And knowing this half-life, can we go 3, 6? Okay, nice job. All right, the biological half-life of I-131 in a particular patient is 30 days. The physical half-life is 193 hours. If the patient's thyroid is counted with the thyroid probe detector, what effective half-life will be observed?
Was it B?
Nice job, Rachel. Excellent. All right, so you could use either one. I think Dr. Karish likes to use this one. I like to use this one, whichever way you like to do it. Excellent job. All right, a radioactive source decays from 20 millicuries to 2.5 millicuries in 18 hours. What's the physical half-life?
Six hours.
Nice job. Excellent. These are very typical board kind of questions. Good job. All right, a sample shows a count rate. Here we're back to our little standard deviation friend. A sample shows a count rate of 36,000 CPM during a 3-minute counting period. Express this count rate as plus or minus the standard deviation. Which of these is the answer?
Was it B?
Nice job. Was that Rachel again? Good job, Rachel. Absolutely. Nice job. All right. Let's see. A long-lived radioactive source is counted for 1 minute and yields 10,000 counts. If this source is counted immediately again, there's a 95% probability the result will be in the range of what? Do you guys remember this one? The confidence interval? This wasn't Dr. Kirsch's massive PowerPoint, I believe. And I think you did math book ones on this one too. Right, if you don't, does anyone remember it? No? Okay. All right, so 10,000 counts at 1 minute, 95%. So there's these probability percentages and confidence intervals. And 95% is usually the two standard deviations. 99% would be one. So it's C is the answer, 9,800 to 10,200, and it has to do with these percentages. So it depends on the Gaussian distribution and the standard deviation from that. So if we have if we want to fall within 1, 2, or 3 standard deviations. So if you guys don't remember these, I'll give you a couple samples of the bell curve, the standard deviation, and the confidence intervals of what you're looking for. I know we did a couple basic questions on this, but I'll review that again. So it's the 68%, there's a 95%, and then a 99% confidence. All right, how about this one? What is the mean of the following 5 numbers? Basic board question if they want to ask if you understand what the mean means. Who got it?
B.
Nice job. All right, so you've got the mean. All right, what's the standard deviation of these? Whoever gets it first, go ahead.
Is it C?
Nice job. Excellent. 2.15, C. Nice job, Teresa. What is the coefficient of variation, CV, of the following 5 numbers? Answer it just like you did with this one, the standard deviation. Coefficient of variation. Anyone get it? Very similar to the last one with standard deviation. All right, it was A, 34%. Standard deviation is that percentage of the mean value. which it's often called coefficient of variation. So it's just to make sure that you know, they're gonna use different words. They're just asking the same thing, okay? Called the percent standard deviation or coefficient of variation, okay? So just don't be tricked. It's the same thing. All right, a thyroid uptake dose of 10 microcuries is equal to how much radioactivity in SI units? So just a conversion. Which one of these would be right?